So you have physical machine here. Okay, this is your physical machine. Okay, and then this is your virtual machine. Okay, so the difference between these two is you will be virtualizing the hardware here. Okay, here your hardware will be virtualized. Okay, so here, so you will be using this. Sorry, this is hardware. So you will be using direct hardware here. Here your hardware will be virtualized. Okay.
Sir, could you please share the screen?
Oh, sorry. Physical machine. Okay, this is your physical machine where you will be having your hardware. Okay, direct you will be running it on the hardware. Okay, so you will be leveraging your physical resources there. Okay, so directly you will be accessing that. Okay, and then you have your hardware drivers here. Okay, so this will be your HAL, hardware abstraction layer or devices, where you will be directly accessing this. Okay, you will have a advantage here. There will be no layer between your operating system and your hardware. Okay, and you have operating system here. The operating system, okay, either it will be Windows or Linux, and then on top of that you will be running your application here. Okay, this is how your normal physical machine or your laptop may work. Okay, so you will have direct access to physical layer. This is the advantage of physical machine. We will see drawbacks also. Okay, so now we will see the advantage of virtual machine. Okay, so now I am doing a physical hardware. I am leveraging it, the hardware here. So I will install the complete guest OS. Okay, so I will install one virtual machine. Okay, so it can be Windows or it can be a your Linux also. So the hypervisor, it should be coming here. The diagram is wrong. Okay, so hypervisor, it will be here itself. Okay, let me put this diagram here. Okay, so draw here. Okay, so your hypervisor layer will be here. Okay, so where you will be leveraging the hardware here. Okay, so on top of it you will be running the virtual machines. Okay, so here what you are doing, you are leveraging the hardware here. Okay, let's say you are utilizing 80 to 90% of the hardware. Here you are utilizing only 2% to 10% of the hardware. Okay, but you will get full performance here. Okay, so here you will get the maximum performance for the virtual machine. You will be using the hardware very efficiently. Here you are not using the hardware. Okay, so that is why we got the virtual machine concept from 2007. Okay, from earlier 2007, this has shifted into this environment. So virtual machines. So I am aware of this from 2007 only. Okay, so earlier they started using it from 2005 to 2004. That was still in research. Okay, so commercially this came into existence from 2006 or 2007. Completely this came commercial of the virtual machine concept. Okay, so now even though I am using this, okay, so here I am using only 2%. Again the same problem. See, you resolved it. Now let's say you are using 2% and then 2% and 2%. Okay, so I have memory here. Let me erase this. Okay, so I am erasing this. Okay, let me give you. Okay, here you are using only 2%. Let's say this is your 8 GB RAM. Okay, this is 8 GB RAM. Okay, so you have given it here 2 GB. Okay, and here 2 GB and here 4 GB. Okay, so you can give one more also 2 GB virtual machine. So you are running 4 VMs here. Okay, or else you can tell in cloud you have 4 instances. So I am not calling it as a virtual machine. Okay, so you are running 4 instances now. Okay, so what is the problem with virtualization is, okay, you are using this. Okay, let's say your CPU is you are utilizing 80 to 90%. Okay, but whereas your guest OS inside that it is still 2%, 2% to 10%. Okay, on an average I will take 7%. Okay, 7 into 4, still I am using the inside OS. This is only 28% I am using. Here I am using 7%. Here I am using the complete. Okay, only 28%. Okay. However, the hardware I am utilizing it, but this is not being utilized. Okay, let's say I will take one example. So I have a kid. Okay, so the kid, what he is doing is, okay, so whatever you make a dish, okay, he will just eat one morsel, means only 1 spoon or 2 spoon he will eat, that's it. Okay, so let's say I will erase all this. I will take that example. Okay, so this kid, what he will do, okay, you make a dish, he will eat. Okay, once you have, he will eat only 1 morsel. Okay, or 1 cup, not cup also, 1 tablespoon. Okay, so that is just 2%. So in virtualization you made a how many dish? 1, 2, 3 and 4 dish. Okay, so this kid is eating, okay, only 1 tablespoon here. After that he will tell, no, I will not eat, that is enough. Then again here 1 more tablespoon and 1 more tablespoon and 1 more tablespoon. That's it. I am done. I will not going to eat. I am not going to eat. So this is the problem that we are facing. Okay. So with container, now we will have a container concept. Okay. So I am not going to virtualize the hardware here. Okay. So I am not going to virtualize hardware. I don't want this hypervisor here anymore. I will directly virtualize the OS here. Okay. So I will run a container engine. Okay. Then I will run a application here. Okay. So this is my dish. Okay. So application, whatever you have, let's say you are running one container here. Okay. So one more container, one more container. So one more container. Okay. One more container. Okay. So I can run n number of containers here. Okay. So all I am using it here is, okay, this will take me, let's say this is your application. Okay. 10 MB I am using. Okay. This also I am using 10 MB. So now we are giving the kid, okay, take this 1 morsel, okay, 1 teaspoon, okay, 1 teaspoon, 1 teaspoon, 1 teaspoon. So until he get filled, okay, you will be creating like this, okay. So multiple OS, you will be pulling it and you will be hosting it, okay. So what happens in container is, okay, so you have it, this is your physical box, This is your physical box, and then you are putting hypervisor, then you are putting VM, okay. After that you are putting the OS, then you are putting the application here. This is how the pattern for your virtual machine. Here you are having hardware, okay, then your device drivers, okay, everything will be here only, okay, then OS, then your application, okay, directly you are accessing, okay. So now here what you are doing, this is your hardware, I will put OS here, and then I will be putting the container engine here, okay. So then I will be running the containers here. So where these containers, I will pull it from the Docker Hub, okay, images, whatever I want. If I want Linux, I will pull. All this should be all open source, okay. So if you are pulling Windows, then they will ask, okay, where is the license for this? Why you are using this container? So where is the license? That is why mostly we will be pulling the open source only, okay. So you have Alpine Linux, okay. Then you have RHEL. This is also enterprise. We will not use this. We will be using Rocky instead of RHEL. You will be using Rocky or Alma Linux, okay. So that is why I was telling you to work on this, or you can use the Ubuntu here, okay, or Fedora. So what you will do, this is the public registry here, Docker, okay. So you want the OS, Rocky Linux, what you will do, you will pull this image, okay. So once you pull it, it will check, okay, whether I have a local copy or not. It will first see, so do I have local copy? If I am not having, I am going there and I am pulling it. I will copy that image inside my OS now. So on the hardware, on the OS, I will download the image. Once I download the image, let me go further here. Okay. So this is my hardware, okay. This is my OS, okay, and this is my container, okay, container D, okay. So once you pull the image, so you will get a read-only image here, okay, your image, okay, we will call it as image, okay. It can be your any open source, okay, either it is Rocky Linux or your Alpine or any. So you will have a bunch of OSs. You can pull any image. Once you pull it, this will come inside your OS now. Okay. Once you have OS in this, you will run the website now. Let's say you want to run website here. Okay. This will cost me only 2 MB here. Okay. If I want to run, I will be running here only 2 MB web, okay, here also 2 MB. So I can run 100 websites just with 200 MB memory. So my OS is Rocky Linux, okay. If I want to use the other one, okay, Alpine Linux, I will be using that, and then I will be using. If I want to use Ubuntu, I will pull this image and then I will be using that, okay. So I will be hosting this web server. Let's say I want to host a database here in the same container. I will host the DB here, okay. I will pull the image Ubuntu, okay. So then I will be running here Postgres instance 1, 2, 3, 4, 5, 6, 7, okay. So websites, let's say website I am doing it on Rocky Linux, Okay. So this I will pull the container. Okay. So then I will be running the websites here. 100 websites I will be running on the Docker here. In the same container. In one container I will be using this. Okay. So now you can ask, okay, why I should be using this OS when this is being used as only 2%. Okay. That's very interesting question. Okay. Yes, you are right. Okay. So what you can do, I have a hardware here. Okay. So what I will do, I will install a hypervisor. Okay. Then I will put a VM here, one VM, two VMs. Let's say I will put three VMs. Okay. On top of this, I will install the container here. Okay. So then in that I am going to use the applications here. Okay. So here also I will use one more container. So then I will use the applications here. I can run multiple containers also here. So I will be running here 10 containers in this VM, 5 containers in this VM and 2 containers in this VM. Okay. In again one container I will be running hundreds of applications. So that is why we have a containerization concept. Most of your DevOps workloads, your application will be hosted on containers only. Okay. Because you are going to use the operating system very efficiently with this app, with this containerization concept. Okay. So we'll go back to the documentation now. Okay. So our supporting content, what exactly I have prepared it. Okay. So now if you read it, so you will get all that logical answers here. Okay. I will remove this navigation pane. Okay. Then I will zoom it little bit. Okay. So you have a layer breakdown here. So you have physical layer from the bottom. Then you have all your resources. Then your OS drivers here. Okay. So operating system, it will be managing all the resources and it will be running directly here. Okay. So in the virtual machines, okay, you will have hypervisor here, okay, where your hypervisor will be a broker here between that. Okay. So you will be utilizing your virtual hardware. You will be assigning this and making a slices of your hypervisor and then creating the guest OS here. Okay. So whenever we talk about virtualization concept, we will use it as a guest OS. Okay. Whenever we speak about cloud terminology, we will change this to instance. Okay. So now if you are looking from the container perspective, what is the difference here? So you will be not using any hypervisor here, either your VMware workstation or VirtualBox or Hyper-V, KVM, nothing. You are going to use any hypervisor. Okay, I don't want all this. I will put everything on the host kernel, host OS. Okay, and on top of it I will install the Docker engine. So I don't want any more layers here. Okay, okay, if it is not being utilized also, I will put multiple containers. I will make sure that host OS is completely utilized. Okay, now you see it here. So each layer, okay, physical hardware, then you have virtual resources here. Okay. So then you are assigning the t-shirt size here on the virtual hardware. So then you are putting the complete guest OS here. For each VM you are putting the complete OS here. So that is where the container concept came. I don't want to put every OS now and then. I don't want to have multiple copies. I will just pull the images. Okay, application and dependency. Okay. So here key characteristics, if you see, each VM has its complete OS. Okay, so you are doing at the hardware level virtualization. So you are making it the hardware virtualization, so that you have a strong virtual isolation between the VMs here. Okay. So higher overhead means, so for OS you need to give the complete RAM here, 2 GB, 3 GB, 4 GB. So that is my overhead here. So even if you are not using also, I have given you that what is that RAM here. Let's say we have 3 kids. Okay, so I am giving them full box of breakfast or lunch. Okay, so nobody is utilizing that complete box. Okay, they are just eating only 5% and they are throwing it away. They are just eating 5% and they are throwing it away. Okay, I don't want to happen that. So what I am doing it here is, okay, so I am not going to give you the complete tiffin box here. I will give you the morsel here. Morsel means in what in your language what it call. Okay, in Telugu we will call it as mudda, means one morsel. Morsel means one time if you are taking it and eating, that is called morsel in English. Okay, so here you are giving, okay, I will give you how many morsel you want to eat, just that one. Okay, after that I am not going to give any more. So this way you are going to utilize your complete OS. Okay, so now here, so when you want to start a VM, boot time will be lower. It will take minutes now. Okay. So now you have here container concept. Okay, so container concepts, this is reversed now. Okay, so you have physical hardware here. We are coming from top to bottom. Earlier it was bottom to top. Okay, so now you have your host OS. Okay, so this is, I am using it on the Linux only. Okay, so if you are running it on Windows box, so still you need to have a Linux here. If you don't have Linux, it will not work. So then you can ask, how come it is running on Windows laptop? Okay, so Windows laptop, what it will take? Okay, I will take this diagram. Okay, I will make a copy and I will take back into the notes here. Okay, so how it is working? Let me take it. Okay, the example here. I will write. Okay, Hyper-V or WSL, Windows subsystem for Linux. Okay, so if you want Docker to work, okay, this is your hardware. Okay, so you have OS here. This is your OS. This is Windows 11. Okay, now we want to install Docker here. Okay, so Docker engine, this is Docker daemon. Okay, daemon means you need to have Linux here. Okay, so what Microsoft done? Okay, after lot of pressure. Okay, so I will give you one piece here. Okay, make this as Windows subsystem for Linux. Okay, you want to run Linux, right? Okay, you come and run here. I will give some share here inside my OS. Or else if you don't have, I will install it Hyper-V here. I will give you Hyper-V layer, virtualization layer. Okay, so where you use my virtualization. Okay, and then you run your OS here. So this Ubuntu okay, or some Microsoft store, you put that OS, okay. Once you put in that OS, then it will, Docker engine will run. Okay, that is how it is going to work. Okay, that is at the architecture level. Okay. Why it came like this symbol? Okay, so now you have host operating system, you have Linux kernel, whether you have it Windows OS or Linux OS, it doesn't care. See, I need a Linux kernel to run my container engine or the container daemon here. Okay, so these are all the processes. Okay, Docker or Podmon. This is your runtime. Okay, only once you have this, then only you will be able to run it. Okay, so this is my container 1, this is my container 2. Okay, let's say this is my Red Hat or Alpine Linux, or this is my Ubuntu, and this will be my Fedora here. So if I want to run any application, I will be running here my applications here. And then I have a shared kernel OS virtualization. Okay, so all my whatever I am running it here, I will be using this host kernel, host operating system here, kernel. Okay, so this you have virtualized it. This layer you are taking it up. Okay, so this purple layer will be here. Okay, at the blue layer. On top of it you will have it. This is how it will work. Okay, so this is just for your understanding. So the AI has created here. Okay, but this layer will be at this level. Okay, that is how it will work now. Now you see it, the boot time is very fast here. Okay, I already have a OS. If you are starting container, I will just use the files here. I am not going to start anything here. Okay, if you are starting VM, you need to start the complete OS here. Okay, so here in Docker engine, I am just using the host OS here. If you are asking me to start, I will start immediately. So that is the added advantage here. Okay, so you can read it now. It will be all understandable now. Okay, so now I will open up. Can someone open your containers and show? So I am starting the recording now. Okay, so these are the installation steps here, how you are going to install. This is how you will update it, and then you will be updating all the core plugins also. Okay, so now you are adding the Docker repository here. Okay, so which is not included in your Fedora repository. This is not an official. Okay, so once you add this repository, it will now go and install the Docker from docker.com. Okay, if you install this, so then it will pull it from this repository, or else it will not check. Okay, I don't know what Docker CE is. Okay, so once you add the repository, then only it will know. So I have an installation here. I will check it from this repository, then I will install. Okay, once you install, you are going to start it, and then you are going to enable this. So if you are enabling it, then it will work at the boot time. So once you done it, you will verify it with sudo docker version. Now you should be seeing now both client and server versions. Okay. So this will be simple client and server, not the 3-tier architecture. Directly it will be running your client and server model. Okay, so now you are making it to run as a normal user. Okay, so sudo, without sudo you are going to add it into the Docker group here. So once you add into the Docker group, you can just directly run Docker version, then you will see that. Okay, So now I will show you, okay, what is the Docker version. Okay. Docker version. Okay. So this, it is showing me all that details here. So what is the version? All that whatever I am doing here on the Docker part, it is giving me that details here. Okay, I have not added. Okay, I will use the sudo here. Okay. So because I have not added that particular user group, that is why it says you don't have access. I am not going to give you the complete details here. So this is my client, okay, and this is my server here. Okay. So now I am going to see how many containers I have installed. Okay. So let's say if I run this Docker run hello world, it will check whether the hello world container is present in my system, or it will check, okay, sudo docker, okay, what is the command here, sudo docker. So I am going to run it, run, okay, hello world. So I am just trying to run whether there is a hello world container or not. Okay. So now what it will check? It will check whether this is present locally or not. You see it here, unable to find the image hello world latest locally. Okay. This is, so it will fail. Okay, because I don't have the hello world. Okay. So it will run once. So what it will do, it will try to pull that image from the Docker hub and then it will run. Okay. So now it is, there is getting timeout here, that is why it is not running. Okay. So on the Docker desktop you will be able to run it here. So for now what I will show you, so I have done one project here. Okay. Sudo docker ps here. Okay. It will list all the containers that I am running it here. Okay. So this is how you are going to run a container here. We will stop it, start recording. Okay, so if you see it, okay, so I am running a container here, Rocky Linux. Okay, I am running SSH also, and then I am doing a web servers also. Okay, 3 days ago I have created. Okay, so 9 minutes ago it started. Okay, so this I am running the port 222 on my guest OS, and on the container I am connecting to 22 port here. Okay, so there is multi-web. I will show you what exactly this is. IF config. Okay, so I have an IP address here, 192.168.1.38. Okay, so I am running it. How many websites? I am running 100 websites from port 8080 to 8179. Okay, I will check it. 1.38. Okay, let me open one website here. Okay, so I am opening a website here. which is 192.168.1.38, okay, which I am running it on port 8080, okay. See, whenever you run a Docker daemon, okay, so it will be running the networking here with this IP address, okay. So let's see what happened here. 8081. Let's see. Two 168 1.38. So let me open inside. Okay. So I don't want to see whether there is any firewall or not. Okay, we open it inside. 192.168.1 dot 1.38, okay, port 8080. Able to connect that. One. We need to check why this is not